Okay, this is a recording that corresponds with some of the material that is in Chapter 6, which is summary queries and aggregate functions, those kinds of things. I've got our old friend, the musical instruments database, although I've actually modified it somewhat or significantly since the midterm exam. Let's go ahead and take a look at it real quick. So instrument families, this is what used to be instrument timbres, I think it was. And this is now ID and family, so this makes a little bit more sense, talking about families of instrument, strings, woodwind, brass, percussion. And then the Baroque orchestra looks largely the same, I think. What I've done is I've added a fourth column here that is the number of players in each of these sections. So yeah, there's one harpsichordist, there are 3 first violins, 3 second violins, and so on and so forth. And let's go ahead and look at the classical orchestra. This is the one I think I'll be using today. Same setup, right? So ID, instrument, the family ID, so what kind of instrument is it? Is it string? Is it woodwind? And then the number of players in each. You can see the numbers are a bit larger in here, and there's a bit more in the way of sections for the classical orchestra. So let's go ahead and get started with some summary queries. So I'm going to use not AP, but musical instruments. And there we go. And let's start off by just repeating that simple select all from classical orchestra. Really wishing that I'd come up with some shorter names for some of these. I stumble a lot when I'm typing them. Okay, so this is just that we can come back and reference this if we ever need to, the number of players in each section and so on and so forth. So let me go ahead and do a summary query with an aggregate function. So a summary query is basically any query that instead of returning one or more rows, only returns one row, or perhaps one row within each section of rows. So I could say, yeah, I'm going to return the overall sum of the players, like how many players in the orchestra overall. That would be a summary query. Or I could say, okay, how many players are there within each of these families? So how many strings are there, how many woodwinds are there, how many brass are there, and so on. So let's just run through those real quick. I'm going to do, well, first of all, let's do another simple one here. And I'm going to copy this. And I think these 3 lines, I'm going to copy those because I'm going to be using those a lot. And so let's go ahead and do select players. So it's somewhat simpler than the one just above, and it's only returning the one column, but you can see that it's still got a bunch of different entries in it, right? It's got one entry for every section within the orchestra. So instead of doing that, let's just return one row. And instead of just saying players, we'll create a number of columns using these aggregate functions. So I will start off with just a count. And this is probably the simple one. You don't even put in, well, you can. You can actually put any column in there you wanted to, but it's kind of conventional just to do select all, because what you're doing is you're not grabbing data from any of the rows or columns, you're just returning the number of columns here. So this would be a way of saying, okay, how many sections are there in the classical orchestra? If I do this, it turns out there's 12. So between first violins, second violins, all the way down through the timpanist, there are 12 of those sections within the classical orchestra. So let's do a few others. The rest of these I will be retrieving from the players column. That's the one where it gives the number of players per each section. So I will do, let's just say min players. And so this will return the row that has the smallest number of players. And in this case, it's our poor lonely percussionist. There's only one timpanist in the classical orchestra. And so here we go. So this is the count of everything. Maybe I'll do a simple as here to make it clear what that's doing. Rows. Okay, and then min players, I'll leave the rest of these alone. So there's the number 1. It's the minimum value within that. There's only one percussionist. Let's go ahead and do max players. And so this next column, 9, there are 9 each of the first violins and second violins. I believe it grabs the first one of them if they're equal. I will have to test that at some point, but I think that's what it does. There are a couple others here. We can do an average. So average ABG players. And that will return the average number of players. And it turns out there's 3.8333 players per section on average. So maybe we should go ahead and add in one of the other functions that we've learned here. Maybe I'll do a round. And I believe this is the one where I don't even need to put in a second argument. I think it'll just round it to 0 decimal places if I do that. And there we go, rounded it up to 4. We'll do one more. Actually, yeah, we'll do one more. Actually, probably the most important one, which is sum. Not average, players. And in the sum of the players, what it did is it added up all the values. So between 9 first violins, 9 second violinists, 6 violas, and all the way down to our 1 timpanist, it all adds up to 46 players in the orchestra. So that's what these guys all do. Count is kind of the odd one out because it's not grabbing any values. It's just counting the number of rows returned, and that is it. So let's go ahead and do some more specific ones regarding, let's see if I still got that. I do. Cool. I'm going to try to keep using that as I can. So I'll go ahead and do that last one again, the sum, and we'll just make it a little bit more explicit about what we're doing. So I'm going to do sum players, just like before, as orchestra size from classical orchestra. And that gives us that same response as before, where there's 46 players in classical orchestra. There's a lot of musicians. Let's go ahead and add another column. So this is where things start to get a little bit tricky, although really you just have to remember the order by clause in order to make this work. What's happening here is that this aggregate function is returning a summary query, which means it's only grabbing one row, right? If I add another column that does not have an aggregate function in it, then it's going to be returning multiple rows. And so that could be a problem unless we fix it. So let's go ahead and do this. We'll start off the same way. Sum players as orchestra size. And before that, we're going to grab another one. Let's go ahead and grab family ID. So the family ID is just a numerical key that, actually it's not a key. Later on, once we do this a little bit more thoroughly, we'll start using foreign keys and so on. But right now it's just it's an integer that's referencing the ID within the instrument families here. That's all. So select family ID, sum players as orchestra size from classical orchestra, and then I do this, and I'm getting, okay, so this is weird because this is giving me different result grids than what I'm getting on my other machine. And all I can imagine is that there are slightly different preferences on the MySQL data. But see, if I try this on my other machine, it gives me an error down here. It won't return it because we've got one aggregated column and one that's not aggregated, where it's trying to return a total number or more than one row. What it's doing here is it's just grabbing the first family ID and then leaving the rest of them alone. So it is returning one row. It's allowing you to do that. But I don't know, test it on your machine, because on my other machine, like I was saying, this exact code generates an error on my other machine until I do this. So after from classical orchestra, I am going to do a group by clause. So let's group by family ID and check out what happens here. We're going to get a slightly different result here. And now we're getting 4 different rows. So what it's doing is it's saying, okay, let's grab each discrete entry or value rather in family ID. So there's 1, 2, 3, and 4, strings, woodwinds, brass, and percussion. And then add the sum of the players for all the rows that have that same family ID value. So everything that has a family ID value of 1 is those strings, which is the first and second violins, violas, cellos, and double bass, 5 rows. And then adding all those up, you get 33 players. And then the number of woodwind players is 8, brass is 4, and then there's our 1 rolling percussion. So this is the way it's really supposed to work. If you're not getting an error when you did this before the group by ID, like I'm not getting an error, then that just means you have to pay more attention to it to make sure that your query is actually doing what you want and what you expect of it. So normally speaking, if you have one aggregate column and the other one not, then you have to do a group by, and you group by usually the one that is not aggregated. In fact, I think it would have to be the one that's not aggregated. Okay, let's do the same thing with a join, because I think this family ID is not very happy. I want to return the family, and we've done joins before. This is not going to be anything new for you, but just so we have done it, let's go ahead and do it. So family ID, and we did the sum of players as orchestra size from classical orchestra, and let's do a join, and this is going to be instrument families. And I better give these guys an alias here. So this one I will call CO, instrument families is F, and then of course we need an on, and it's going to be co.familyID equals f.id. And then we still need to do that group by. So group by, and here we can use either family ID or family. It comes out to the same thing. So actually the whole point of doing all this was to get family up here instead of family ID, because these numbers, they mean something to us, but they won't necessarily mean something to someone else grabbing the data. And then we can grab from the other table, and instead of 1, 2, 3, 4, it says strings, woodwinds, brass, and percussion, and then we've got, actually this should not be orchestra size anymore, should it? This was orchestra size up here because we grabbed the sum of all the players. This one should be family size. I'm not going to copy and paste that because I've got something else on the clipboard. There we go. That makes a bit more sense, doesn't it? Family size of each of these. There are 33 string players, 8 woodwind players, 4 brass players, and 1 percussionist. All right, cool. That's looking good. Now, I also want to do, there's a couple more things to pay attention to from this chapter. One of them is having clause, and the other one is with roll-up clause. So let's go ahead and do those one at a time. I'm going to do something similar to this last one, but I'm going to simplify it back down a little bit. I'm going to get rid of the join. We don't need to do that every single time here. But I am going to do select family and do that count again from all the way upstairs as so what I'm planning on doing here is I'm going to once again group by family. So if I'm not doing a join, actually that better be family ID. So I'm going to group by family ID 1, 2, 3, and 4, and then we're just going to count the number of sections in each of those. So there are 5 sections within the strings, so we should get 5 here. I think there are 4 in woodwinds, 2 in brass, and again 1 in percussion. And let's go ahead and try this out. So let's see, after from classical orchestra, we need the group by. And once again, it'll be family ID. Type a little slower there. And there we go. So we get the response there, family ID 1, 2, 3, and 4. We know what those mean. And in each of those, it gives the corresponding numbers of the sections within those family. 5 sections in strings, 4 sections in woodwinds, and so on. Let's go ahead and add a having clause here. So having count greater than 1. So we want to leave out our poor percussion. Maybe it's being a little bit depressing for us to always see our percussionist down there alone. And we want to not return that section when we get our result. And so it's just returning those first 3 families with the number of sections in them. So, so difference between having and where, because in this case you could do this as a where clause and it would get you the same thing. Oh, no, I'm getting an error here. Okay, no, I get why. So let's talk about why. Let's get that result back again. Having count is greater than 1. So what the difference is, the textbook kind of glosses over this, which I was kind of disappointed by. Overall, the textbook has been great, but this is one of those places where For having, it just gave you like one little paragraph that says like, oh yeah, having can be used interchangeably with where. So if you want to know how to use having, just look at the last few pages of where examples and use having in some of those. We've just seen actually where I was tricked into that, but it's not actually the same thing. So the basic technical difference is that where should be performed within the query itself upon the original table. So actually where, if I were going to use where, I would have had to put this up after from classical orchestra and before group by family ID. As soon as we do group by family ID, what we're doing is now we're now talking about the results grid, the result table, instead of the original table or tables that we're pulling from. And that's what having does. So I had actually forgotten about this until the reading kind of made me tweak my head a little bit about having, I kind of glossed over it, and that jiggled my memory. I've totally forgotten about something that you can do with having. This was something that we came up with earlier, or we talked about earlier, rather. Let's say, okay, so my example is, let's say I want to return just the timpani, and I want to give it a different name. So I'm going to do a select instrument as, I don't know, jingle jangle from our classical orchestra. I guess I could have copied and pasted again, but anyway. And then we do where instrument equals timpani. And what that does is it returns timpani as the one value in the jingle jangle column of the result grid, right? Jingle jangle has nothing to do with the original table. It just exists in this table down here. Now, we've talked before about, hey, wouldn't it be nice if we could take these aliases and use them down here? And of course, I can't do that with where, because where references the original table and jingle jangle is not in the original table, so I get an error. But watch what happens if I do having instead, and then boom, it works. So this is something that you asked before, and I was saying, oh yeah, you can't really do that. I was wrong. I was forgetting. You actually can do that if you use having instead of where, because having references the result grid. So happiness. So in this case up here, instead of having count as greater than 1, I could use section in family if I wanted to do that instead. I mean, it's no shorter, right? But at least I'm not repeating the count operation, and then that returns the same thing. So that's having. Having is like where, but it references the result grid instead of the original table. Okay, I'm going to do one more, and I think this time, this is the last one, so I can just copy this guy here. I'm going to do the same thing here. I'm going to use with rollup for this one. So let's see. And I'll just go ahead and replace this one here. We don't need that in there. So if we group by family ID, with rollup means it's going to take the aggregate function here and count them all up. So it's going to give me the sections in each family, 5, 4, 2, and 1, and then underneath that it will include an extra row where it adds all these guys up as the orchestra size. So this will happen, you put this right underneath the group by, and we'll do with rollup, and there we go. So 5, 4, 2, 1, add them all up, and you get 12 down here. So we can return, like before we did a separate query, grabbing the number of sections in the orchestra, but we could actually get the sections in each family and the sections in orchestra all at once by doing with rollup here. And of course it returns null over here when it's got an extra row there. Okay, I think that's the important stuff from chapter 6. I will stop the recording there.